Hello guys and welcome back to Easy Stats with Danny. So in this video we'll be doing exam preparation. As you know that we've done all the study units and now we're preparing for the exam. Otherwise, congratulations to those who qualified to write the exam, and then yeah, good luck with the exam as well. Now, with me here, I have the 2022 question paper for Statistics 124. You might have seen the question paper before, some of the questions from this question paper. You might have seen maybe the memorandum or maybe the solution to some answers. But I'll be doing this question paper just to show you how some of them were actually found, some of the answers were actually found, or maybe to explain some of the parts that you might have not understood even though you saw the answers. Now, on the left here is the question paper, and then here is where I'm going to be writing the solutions for those questions. Now, without further ado, let's go right into it. Uh, Here are the instructions, so you'll read the instructions. So the question paper is going to be like similar to this in terms of content. Over the years, they've changed how they said the question papers. I've seen last year, I think, it had two sections, whereby section A, you had to write uh, everything, and then section B was the multiple choice, or vice versa. I don't remember quite well. But yeah, it had two sections, whereby one you have to answer the questions exactly, and then the other was just multiple choice. So you might write a similar question paper. If that is the case, then it means uh, one of the parts was going to be easier than the other, especially the multiple choice. Now, uh, let's just go into the questions. We have the first question. So okay, before we actually do that, what I want to tell you is the question paper is going to be in order, especially the parts of where it's not multiple choice, where you have to actually write down the steps and everything to show how you got the answers. It's going to be in order of the study units, meaning the first one is going to be study unit 1, followed by study unit 2, and so on and so on. So you need to know your study units. As you have your notes, you have to have them in order so that it's easier for you to know where to refer to if you need to refer to a certain chapter, and work your way through that. So question one here is from study unit one, and study unit one is all about multiple regression and correlation. So you are a public health researcher interested in social factors that influence heart diseases. You gather You survey 30 towns and gather data on the percentage of people who smoke, which is denoted by X1. So as you read the questions, what I can actually tell you is you should make notes as well. Let me just use this one over here. You should make notes as you read your questions. Where is that question? I want this thing off, man. You should make notes as you read your questions. Okay, it's okay, I'll just make those notes here. You are a public health researcher interested in social factors that influence heart diseases. You survey 30 towns and gather data on the percentage of people who smoke, which is noted by X1. The percentage of people who ride bike to work is noted by X2, and the percentage of people who have extremely stressful jobs, which is denoted by X3, and the percentage of people in each town who have heart diseases, which is Y. So we are determining the value of Y based on the people who smoke, the people who ride bike to work, and the people who have stressful jobs. Now, you use a multiple linear regression to analyze the relationship between these variables and obtain the following stat 1.2 output. Use the following information to answer the following questions. Now, they will give you a stat 1.2 output. You won't be asked to do that because it's a computer program and you're not using computers for stats 124. Now this is the multiple regression output, and we have uh, the model fitting statistics, regression coefficients, and then the contribution of variable to R squared. Now there are questions that follow after that. There are questions that follow after that. So here is your variables. So you need to understand these variables, you need to understand these regression coefficients and all that. So the first question says, provided that the Pearson's correlation coefficient between heart disease and biking is R equals minus 0.91. Comment on the type and strength of the relationship between these two variables. Now, what we know about the Pearson's correlation coefficient is that it's always between minus 1 and positive 1. If it gets closer to minus 1, it means it is strong. And the sign tells us that it's negative. So this tells us that the strength is strong, the type is negative. So you're going to say there is a strong negative linear relationship between heart disease and biking. Between heart disease and biking. Just like that. There's your answer for 1.1. There's your answer for 1.1. There's a strong negative linear relationship between heart disease and biking. As you can see, they said between heart disease and biking. That is question 1.1. 1.2, state the coefficient of determination r squared and interpret this value in terms of model fit. So r squared is over here. That is the coefficient of determination. So the coefficient of determination is noted by r squared. So they said state the coefficient of determination is 0.9614. 0.9614. That's exactly how you're going to say it. R squared is equal to 0.9614, and then you say the least squares equation fit model, not equation, sorry, the least squares model fits the data well. You can even say very well, actually, very well, because it's closer to 1. Very well. So basically, r squared, unlike the normal Pearson correlation coefficient, it is not between minus 1 and 1. It is always between positive 1, I mean 0 and positive 1. Always between 0 and positive 1. It is never a negative number. So the more it gets closer to 1, it means the least squares model fits the data well. And then if it gets closer to 0, like for example, if this was minus 0.3211, in that case, we'll say the least squares model does not fit the data well. So in this case, because it's closer to 1, then we say the least squares model fits the data well. That's how you answer that question over there. Right, question 1.3. Calculate the value of the adjusted coefficient of determination r squared a by making use of the given coefficient of determination r squared. So now when it comes to this, guys, this question will always be there. This question will always be there. Calculate the adjusted coefficient of determination. There's a formula for this. It says r squared a, which is adjusted coefficient of determination, is equals to 1 minus n minus 1 over n minus k minus 1, open bracket, 1 minus r squared. 1 minus r squared. This is how the formula goes. Now, in this formula, 1 is just 1 minus n is the number of observations. So this is the number of observations. It's 30. So it's going to be 30 minus 1 over, we still have 30 again, 30 minus k is the number of independent variables, also known as the x variables. In this case, we have x1, x2, and x3, smoking, baking, and stress. So it's 3 independent variables, minus 3 minus 1 into 1 minus, what is the value of r squared? We already have it here, 0 0.9614. 0 0.9614. 0 0.9614. Then from here, you just go to your calculator and get that answer. Let's wait for the calculator to open. There we go. So we're going to say 1 minus fraction 30 minus 1 over 30 minus 3 minus 1, open bracket, 1 minus 0 0.9614. Then you get 0 0.9569. If you want to write it to 3 decimal places, you can say 0 0.96957 is equal to 0 0.957. That is your answer. And the the adjusted coefficient of determination will always be smaller than the normal coefficient of determination, but it won't be like that small. If you look at this number, 0.96 I mean 957, and this one is 0 0.961. So the difference between this and this is not that much. It will be smaller than this, but not like a bigger margin. Like you can't find this being 0.9614 and then this one is 0.553, for example. Like 0.5 and 0.9 are way it's a bigger distance between each other. So uh, um, it'll always be smaller than this, but not with a bigger margin. So yeah, that is the adjusted coefficient of determination, and that is question 1.3, 2 marks. So 1 mark will be for substitution, and 1 mark for the final answer. They don't give a mark for the formula because it's an open book, so you already have the formulas with you in your textbook. You already have the formulas in your slides. Now, question 1.4. Write down the equation of the estimated regression line. So there will always be this question, guys, as well, or mostly. Let me not say always, but most of the time this question will be there. Most of the time this question will be there. Can I please do this? Where is my thing? I don't want this thing. I want to move this thing. Right. Okay. Question 1.4. Write down the equation of the estimated regression line. So the equation of the estimated regression line, this is the standard formula, the way in which you should write it. This is not the answer, it's a standard formula. So the actual answer will be under the B parameter estimates over here, under the B parameter estimates. So you're going to write this formula using these numbers here. Now, this is how you're going to write it. You're going to say y estimated is equal to, and then you write these values here. So B0 is going to be the intercept, which is this one, 17.473. So it's going to be uh, it's going to be 17.473, 17.473 plus 0.208. Then you're going to write x1 minus, I'm saying minus because this one is negative, minus 0.229, 0.229, x2, don't forget this, x2 minus 0.357 x3, and that is your equation. 1 mark. You see, it's 1 mark because you don't have to do a lot of things. You don't have to do complicated calculations. You just look at that value over there and then you write that answer. Is that simple? Right. All right. So question 1.5. 1.5, they say sort the three independent variables in terms of their relative order of importance, most to least, by making use of their contributions to the coefficient of determination. Now, this question you're going to focus here on the contribution of the variable to r squared. So you're going to focus on this part of that output. Now, you're going to focus on this part and then you're going to come to this part over here because this is where we see the contribution. Now, the bigger number here contributes the most and then the smaller number contributes the least. So they said we must name them in order of importance. So 0.1221, 0.2940, 0.0087. So x2, 0.29 is the biggest. So it's going to be x2 and then x1, 0.1221 before 0.0087. So the order of importance is x2, x1, and then x3. x2, x1, then x3. So that is the order of importance. So they said just write down the letter of the correct option. So it has to be x2, x1, and x3. So letter B is the correct one here. Letter B is the correct one. So I don't have to write that over here. It's just letter B, x2, x1, and x3. That is the order of importance. If they said from least to most, then it was going to be x3, x1, then x2. So it was going to be option C. But they said most to least. So most to least is 2, 1, and 3. Just like that. Indicate which variables contribute statistically significant to the model. Use alpha equals 0.05. So when it comes to this, if you're going to focus on this numbers over here, we're going to focus on these numbers here, and then the variables we're going to work with is 1, 2, and 3. We don't include the intercept. So it's x1, x2, and x3. So you look at the numbers there. These numbers under the probability. The numbers under the probability. So if any number under this probability is more than the alpha of 0.05, they said our alpha is equal to, they said alpha is equal to 0.05. 0.05. Now, if there's a number that is more than this, it does not contribute statistically significantly. So meaning that it is not that important, even if we don't include it in this or if you don't include in this research, then it won't make a difference. That's what statistical significance means. So that is the case. And then if you look at these numbers, all of these numbers are less than this. We have 0.001, we have 0.001 as well, and then we have 0.023. So in this case, you can say all the variables, you can say all the variables, all the variables contribute statistically significantly. All the variables contribute statistically significantly. That's basically how you write the answer to question 1.6 to question 1.6. Indicate which variable contributes statistically significantly. That's how you answer it. All the variables contribute statistically significantly. 1.6. 1.7. Suppose there's a new town which wasn't part of the original sample with the following properties. Percentage of people that smoke is 68.66. Percentage of people riding a bike to work is 60.27, and percentage of people with stressful jobs is 20.5. What do you expect the percentage of people with heart diseases in this town to be? So remember, for this question, or main scenario, we were testing what the percentage of people in each town who have heart diseases. So heart disease is Y. We determine Y using x1, x2, and x3. And we have a formula for determining Y. This is the determined Y. We use this formula for that. So this is x1, x2, and x3. Now, they gave us some numbers here to work with. So what we're going to do is we're going to substitute these numbers into our formula. So they'll give them in order. So meaning that the first one will be x1, then the second will be x2, x3, and so on. So if you have like maybe more than more than 3x values, the fourth one will be x4 and so on. So here we have only 3, so we're going to substitute it like that. So we're going to say 17.4 473 17.473 473 plus 0.208 x1 is given over here 68.66 and then we say minus 0.229 multiplied by 60.27 and then plus minus 0.357 multiplied by 20.5 over here 20.5 and the answer is 10.63 10.63%. So we're expecting the people in that town to with heart disease to be only 10%. Only 10.63% of people in that town we expect them to have heart diseases. That is our answer over there. So that is how you do the substitution. So basically what you do is uh, you substitute those values into this equation. So the first one is 68.66 followed by x2 60.27. The last one was 20.5. That is how we found that value. So uh, y is equal to, which is equal to 10.63. That is our answer over there. That's our answer over there. So that is how we found that we're expecting 10.63% of people in that town to have heart diseases. And that is question one. That is the question one that we have here. Uh, there are some other questions they can ask from study unit 1. So you must go through the videos if maybe there's something that wasn't asked here. Because remember, this is not everything. This is not everything. There are some questions that they didn't ask here. They might ask them. So now we'll go to question 2. So for question 2, we have study unit 2, vector analysis. We have vector analysis, study unit 2. Now vector analysis, here's a question. In a vector analysis variables of 6 variables, the following variants are explained by the possible vectors. So we have 6 of them. There's one question which says 2.1a says calculate the variance explained by A, which is vector 6. So now if you have 6 vectors and then we have the variance explained by each vector and there's one that is missing, You must always know that the variance explained, the total variance explained by all the 6 vectors should be equals to 6, which is the number of vectors. Now to get the missing one, it's just simple. You just say 6 minus everything. If there are 6, if there were 5, you're going to say 5 minus whatever that you got, and then you find the missing value, the value of A in this case. Now because there are 6, we're just going to say 6 minus 3.26 minus 1.25 minus 0.72 minus 0.46 minus 0.24, and that is equals to 0.07. That is equals to 0.07, and is the answer for the value of A. Now when it comes to this, you must know that the variance explained by each vectors are are in descending order. So this is the biggest, this one is smaller than 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 this, and this one should be smaller than this, and hence you see 0.07 is smaller than 0.24. That is how you calculate the variance explained by a factor, and you know that your answer is correct. 0.07 is the value of A over there. Now, how many factors should be extracted according to Kayser's criterion? According to Kayser's criterion, we only extract factors that are more than 1, that have variance explained more than 1. So in this case, it's only factor 1 and factor 2. 3.26 and 1.25, they are the only ones which are more than 1. All these other factors are less than 1. 0.72, 0.46, 0.24, and 0.07. They are all less than uh, 1. So only factor 1 and factor 2. Only 2 factors. How many factors should be extracted according to Kayser's criterion? 2 factors. So I can just write it here. Only 2. Or let me start by saying 2.1 A 0.07 is the answer, followed by B 2 factors. 2 factors. And then C. So for C, let's see. Calculate the proportion variance explained by factor 2. The proportion of variance explained by factor 2 is over here. So when it comes to proportion, if they don't say percentage, you just take the variance explained as it is. So it's going to be 1.25, 1.25, and then you divide it by the number of factors. In this case, it's going to be 6 factors divided by 6, the number of factors, which is equal to 1.25 divided by 6, and that is 0.208 to 3 decimal places. 0.208, 0.208, 0.208. That is the answer for C over there, 2.1C. 2.1C is equals to 1.25 over 6, and that is 0.208. That is how you answer 2.2. Now, I mean 2.1 C. Now 2.2. An education statistician wants to know whether students who are doing BSc are prone to do better on other theoretical subjects from other faculties. Consider the following output. Now we have the output here of a factor analysis, whereby we have the variables. These are variables: economics, business, psychology, sociology, communications, human resource, Akhle, and marketing. Then we have the variance explained by each factors. We have only 2 factors, and then we have the factor loadings here in between. We have the factor loadings here, and then we have the communalities as well. So there are some numbers that are missing here, and we have to do the calculations of those numbers over there. we have to do some calculations. Now 2.2a 2.2a 2.2a, they say calculate A, which is the factor loading between economics and factor 1. So they say calculate the factor loading between economics and factor 1, which is this value over here. Now to find this value, there are two ways. One way is the hard way and the other way is the easy way. So the hard way would be to use the way in which you calculate the variance explained by saying a squared plus 0.711 in bracket squared plus this squared plus this squared plus this squared plus this squared to get that value over there. It will take time. To do that will take time. So the easier way is to use the communality way. So in a way to use in order to use the communality way, we're going to say a in brackets squared. So this is like simple algebra from grade 9. So you're going to say a squared plus uh, a squared plus minus 0.202 minus 0.202 squared. Pardon me guys, I'm writing with the mouse, so it's not that easy. It's equals to 0.596. 0.596. So now we have to solve for a. So in order to do that, we're going to leave our a on one side, a squared as it is. We're going to say is equal to, then we take this to the other side. It changes the sign from positive to negative. But before we do that, we must find the value of this. Or we can actually do it at the same time. When you take it to the other side, you say it is equals to 0.956 minus 0.202 squared. Now a squared is equal to, then you can put this on the calculator at the same time, say 0.956 minus 0.202 squared. And the answer is 0. At this point, do not round off. You can round off at the final answer, so you can just say 0.915196. 915916. Let me just double check. 915196. 196. And then here, because we don't want a squared but we want a, then you're going to take the square root. A is equal to the square root of this number over here. The square root of this number. 0. Let me actually do this. Control C. Control V. There we go. 0.915196. That is our equation over there. 0.915196. And the value of a is equal to, you find the final answer now. The final answer would be the square root of the answer 0.957. The value of a is equal to 0.957. 0.957. 915. I just want to double check. 196 equals 0.957. 0.957. Okay, so if I did everything correct, 0.957, if I square it and then I add minus 0.202, I should get 0.596. 0.596. So it's actually, if you round it off, it's going to be 0.957 because of I rounded off this final answer here. That is why it is basically different. But you can see that uh, if I substitute the value of a there, it gives me the communality as it is there. So that means our value of a is correct. That means the value of a is correct. So that is how you calculate the value of a. It's important to show all the steps, even if it's just 2 marks. It's important to show all the steps, because in that way you will have all you have all the marks if your answer is correct. If your answer is not correct, you might find that maybe you made a mistake with the final answer, but some of the steps are correct, so you can get a mark or maybe a mark and a half for that particular question. That's how you find that question. And then we can go on to the value of b, the value of question 2.2b. Calculate and interpret the communality of the variable psychology, which is this one, denoted by b. So we're going to say b is equal to, so this is just simple, a very same way we did this, but in this case we have these two. So we're just going to say when I say minus 0.657 minus 0.657 squared plus the other one is 0.232 squared, and the answer is, you go to a calculator, you're going to say you're going to say minus 0.657 squared plus 0.232 squared, and that's equals to 0.485. Answer is 0.485. Is it 485 or 486? 485. That is how you find the value of b over there. The value of b over there. Calculate the variance explained c by factor 2. The variance explained by factor 2. They want the value of c over here. So you're going to do the same thing with that as well. We're going to put all these numbers in brackets and then you square them. You put them in brackets and you square them to find the variance explained by factor c. Another way to do it, you can do it with the calculator. You can do it with the calculator. So you say mode, you go to stat with this 2, and then you're going to go to one variable, say 1, and then for the x you're going to put your factor loadings 1 2 3 4 5 6 7 8. So all those factor loadings, so you're going to start with minus 0.202 minus 0.202 equal, and then you say 0.382 equal 0.232 equal 0.244 equal minus 0.310 equal minus 0.140 equal 0.651 equal minus 0.458 equal. So these are the factor loadings for factor 2. Now when you're done, you press AC, then you press shift, then you press 1, and then you're gonna go to sum. Remember I said you must put this in brackets and you square them. So, and then and then you add them. Adding is summation in the calculator, so that's why we go to 4 for the sum. And then we're looking for sum of x squared. Remember I said you put them in brackets and then you square them, so you're going to look for the sign that says squared. So you press 1, then you say equal. So the answer is 1.049. So the value of c, is equal to 1.049. The value of c is 1.049. So that's how we found it. 1.049. And remember when I said the factors are based in order of importance. So you can see the variance explained here is 3.432. This one was 1.049. So this one is smaller than this. The same thing that we did here. This is bigger, this one is smaller than this one is smaller than this, and so on and so on. It's the same here. It's just here it's expanded using the factor loadings. Here it is just the factor and the variance explained. So it's the same thing. The answer that we got here is actually correct. If you want to do it the other way, you can do it the other way. So it's going to be minus 0.202 squared plus open bracket 0.382, you square it, plus, so the calculator, the way I did it was just an easier way to find the final answer. 0.232 squared plus 0.244 squared plus minus 0.310 squared plus minus 0.140 squared plus, you do it for all of them, 0.651 squared plus minus 0.458 squared. So the answer is 1.049 as we found it there. So you can either do this way or the first way that I did it. But that way is actually easier. You just have to make sure that the data that you input in the calculator is correct. And when you put the data in there, you don't say squared. You just put it as it is. Then you're going to look for the sum squared. But if you do it like this, that is how you do it. You put them in brackets and then you square them. You're going to find that final answer there. That's how you find the value of C. Now let's move on to question 2.3. 2.3 is the factor matrix after rotation. After a rotation is the factor matrix after a rotation. Right. The factor matrix after a rotation. So we have factor 1 and factor 2, they are rotated. And they say classify the variables into factors by using the output after rotation. In other words, indicate which factors have significant factor loadings on factor 1 and on factor 2. So a variable have a significant factor loading if it explains more than 10%. So to get the value of that, we take the square root of 0.316 and also take minus this, the square root of 0.1, which is 10%. Sorry for that. Minus 0.1. So the answer for that is 0.316. So it's minus 0.316 and positive 0.316. I'm just going to show you now where we got those numbers. 0.316. So a factor loading has to explain more than 10% of the variance explained. Now that 10% was divided into two, meaning the negative and the positive side, because as you can see the factor loadings can be negative. So if we take the square root of 0.10, it gives us 0.316. That is where we got that number. And also when you take the negative of that, we get the negative 0.316, which is this one over here. So if there's a number that is in between, this, we say it's not significant. And if a number is this and more, to the left this and more to the right in the positive, meaning the positive and the negative side, then we say that that variable is significant. That factor loading is significant. I mean, we say the factor loading is significant. Now, uh, let's look at economics, for example. We have two factors, and we have factor loading for factor 1 and factor loading for factor 2. So what you're going to do is we're going to look at economics. This number here, 0.703, you can see it's more than 0.316. So meaning that economics is significant in factor 1. Is it also significant in factor 2? 0.028. 0.028 is in between these two numbers. So it is not significant in factor 2. So meaning that economics should fall under factor 1. That is what this question actually means when they say classify those factors. So if you want to classify them, this is what you're going to do. You're going to draw a table like this, and then here you're going to say factor 1. I'm going to say factor 1, factor 1, and then we go to the other side and say factor 2, factor 2. Say factor 2 on the other side, factor 2 over here. Now we already saw that economics is under factor 1. So that is what we're going to do. We're going to say economics. And then let's see business. Business 0.695 significant, 0 minus 0.207 not significant. It's also under factor 1. So business is under factor 1. Let's look at psychology. Sociology. Sociology. Oh no, psychology. Yeah, psychology is significant here and not significant here. Sociology significant, not significant. So we can put psychology and sociology under factor 1 as well. Psychology, and then sociology. Psychology, sociology. Communications significant, not significant. Communications is also in here. Communications is also under factor 1. So it's under factor 1. So these are our variables under factor 1. And then let's go and look at human resource. Human resource, not significant. It's only significant under factor 2. AGLE, not significant, significant under factor 2. And also marketing is significant under factor 2. So we can write those ones in here. Human resources, AGLE, and marketing. So that is how you answer this question here, 2.3a, classifying them into factors. This is how you classify them. So they say, is there a variable that is complex? Motivate your answer. No, there's no complex variables. No, there's no complex variable. Meaning, reason for that, all the variables have only one significant factor loading. So that's how you answer question 2b. Question 2.3b. Question 2.3b. No, all the variables have only one significant factor loading. So meaning that if there were variables that had more than one significant factor loading, for example, let's say human resource, this number was 0.545 and this is 0.909. So it means it will be significant in factor 1 and also in factor 2. So in that case, we'll say it is a complex variable. And if it's a complex variable, it means the rotation was not successful. So if they also ask, was the rotation successful? In this case, you'll say yes, the rotation was successful because there are no complex variables. So the question here was asking about the complex variables. There are no complex variables because all the variables have only one significant factor loading. We don't have a variable here that is under factor 1 and under factor 2. So that is how you answer questions on factor analysis. One of the easiest study needs, by the way, So make sure that you go through that and understand it a little bit better. Right, now question 3. Question 3, we go to question 3 now. Let me actually go higher in this. Question 3, a quantitative risk manager claims that the mean share price of bank ABC is more than 125. A random sample of 20 share prices was taken and it was found that the sample mean was 126.88 and the sample standard deviation was 7.25. Use alpha equals 0.01 to test the hypothesis. Show all the steps and indicate the decisions and conclusions clearly. 3.1. Formulate the null and alternative hypothesis to test the risk manager's claim. This question will always be there, guys. This question will always be there. The null hypothesis denoted by H0 is going to be the main claim, or the mean is equal to, in this case, is 125. So you're going to write 125. So that's what we're claiming. The alternative, the bank manager, quantitative risk manager at that bank says the mean share price is more than. The keyword more than tells us that our alternative hypothesis is going to be more than 125. More than 125. That's how you answer that question. Question 3.1. 1 mark in the back. Now, let me just reduce the thickness. Calculate the appropriate test statistic that can be used to test hypothesis in 3.1. A random sample of 20 share prices. So our sample size here is 20, meaning that we're going to use the formula for T instead of the formula for Z. For T is equal to x bar minus the main claim divided by standard deviation over the square root of n. And what is our main claim? This is 0. What is x bar? X bar is the actual mean, which was found to be 126.88. 126.28. So it's going to be 126.88 minus 125, which is the main claim, and then we divide by sample standard deviation, which is 7.25 divided by the square root of let me make a space to all write the square root of 20, right? So we divide this by the square root of 20. Divide by the square root of 20. Divide by the square root of 20. And our answer is going to be equal to, let's go to the calculator. I'm going to say 126.88 minus 125 divided by 7.25 divide by the square root of 20, and the final answer is 1.160. 1.160. That's how you answer question 3.2. Then 3.3, she's not asked here. Actually, it is a mistake from supposed to be 3.4. You see here they said 3.3, but here they wrote 3.4, so it's a mistake here. It is found that the p-value of the test is 0.132. The p-value of the test is equal to 0.132. 0.132. What conclusion regarding the initial problem can be drawn from this. So this is the p-value. Our alpha is equal to 0.01 as given. So clearly the p-value is greater than alpha. P-value is greater than alpha, and if that is the case, you do not reject the null hypothesis. Do not reject the null hypothesis. We do not reject the null hypothesis, and the conclusion is that we are basing our conclusion on the initial statement. The risk manager was claiming that the mean share price is more than 125. So we say we do not reject the null hypothesis. So we can't say that it is more than 125. So we'll say there is not enough evidence to say the mean share price is more than 125 francs. It's more than 125 francs. You can also say there is not enough evidence to support the risk manager's claim. You'll be given marks for that. There is not enough evidence to support the risk manager's claim. So that is the answer. That is the answer. That is the answer. There is not enough evidence to say that the mean share price is more than 125. Why did I say 80? 125 rands. Do not reject the null hypothesis, which is equal. Yeah. So that is how you answer question question 3. Now question 4. Question 4 is hypothesis testing for two populations. Hypothesis testing for two populations. Both of them are large. Right. So let's read the information. As part of their quality control, a large supermarket regularly weighs the 5 kg bags of potatoes that it sourced from two growers, JC Farms and Pete Bros. The quality controller at the supermarket is concerned that the mean weight of the 5 kg bags of potatoes received from JC Farms differs significantly from that received from Pete Bros. The weights of a recent sample of 49 bags from JC Farms and sample of 64 bags from the Pete Bros were taken, and their mean and their standard deviations calculated as shown in the table below. So this is the situation. Conduct an appropriate hypothesis test to address the quality controller's concern, assuming equal population variances. Right. So what is the null and alternative hypothesis to be tested? So they wrote this in Afrikaans in both. So the one, the null and alternative hypothesis to be tested. So 4.1, the one, the null and alternative hypothesis to be tested. So H0 and HA as always. H0 and HA. So H0 is going to be mean 1 representing JC Farms. So it's going to be mean 1 equal mean 2, and then for the alternative is going to be mean 1 is not equal to mean 2. Because I said we are testing the hypothesis of the quality controller, which claims that the potatoes received from JC Farms differs. The weight differs significantly. If something is different from something, it's not equal to that. So hence our alternative hypothesis is not equal to over there. That's how you answer question 4.1 and get those that 1 mark. 4.2, calculate the appropriate test statistic that can be used to test the hypothesis in question 4.1. So 4.2, because both samples are large, we're going to use the Z formula. So we're going to say Z is equal to x bar 1, which is the mean one, x bar 1 minus x bar 2, all divided by the square root of standard deviation 1 is going to be 1.35 squared, standard deviation, let me write the formula first. Standard deviation 1 squared over n1 plus standard deviation 2 squared over n2, and this equals to 6.02 minus 6.58 divided by the square root of standard deviation 1 squared is 1.35 squared, 1.35 squared over n1 is 49 plus 1.85 squared, 1.85 squared over 64. Then we go to the calculator and find the final answer. And the final answer is going to be, let's see, 6.02 minus 6.58 over the square root of 1.35 squared over 49 plus 1.85 squared over 64 minus 0.02 minus 0.02 minus 0.02 is our set score. Let me just double check. 6.02 minus 6.58, not 59, minus 6.58. So mistakes can happen. You should always double check your calculation. 6.58, 1.35 squared over 49. I said 185. 1.85 squared. 1.85 squared. Answer is minus 1.860. Minus 1.860. You see, my answer was way off. I made some mistakes in the calculations. So always double check your calculations. Minus 1.860. That's how we find that answer. So that is the value of the appropriate test statistic. It is found that the p-value of the test is 0.0315. What is the conclusion? So the p-value is equal to 0.0315. Alpha is equal to 0.05. The p-value is less than alpha. Reject. Null hypothesis. We reject the null hypothesis. P-value is less than alpha. We reject the null hypothesis. Therefore, there's enough evidence to say that the mean weight, the weight, yes, the mean weight. So we can say there's enough evidence to say that the mean weight of the mean weight of 5 kg potatoes from the two farms from the two farms differ significantly. So when you write your conclusions can be uh, written differently, but they mean the same thing. Someone might say there is enough evidence to say the mean weight of 5 kg potatoes from JC Farms and Pete Bros are different. So I wanted to write it in an easier way to say from the two farms. We know that the two farms we're dealing with is JC Farms and Pete Bros. But I advise you guys to write it in full. So I'm just saving time because we still have more questions. So that is question 4.3, and that's how you answer it. Question 4.4. Calculate a suitable effect size that can be used to test whether there's a practically significant difference between the mean weight of the 5 kg potatoes. Yeah, before I answer this question, guys, there is some confusion for other students. They're confusing the statistical significance, which we did in study unit 1 of this question paper, and they confuse it with practical significant and what's the other one going it's practical significant and significant difference. Yeah, so statistical significant is what we did in the first one, tells us which variable is more important, and then practical significant is this one. Practical significant difference is this one, whereby we want to calculate the effect size. So the effect size we're going to calculate, we're calculating the value of D, which is this formula here, the value of D, which is equal to the absolute value of x bar 1 minus x bar 2 minus x bar 2 over the standard deviation that is the biggest. So now most students confuse this with the first one and with uh, study unit 4, analysis of variance, where you need to compare the two groups and see which ones are different in Tukey's groupwise comparison test. So yeah, make sure that you look at that carefully so that you don't make that mistake. Right, so now we calculate the suitable effect size. The suitable effect size would be the absolute value of what is x bar 1? X bar 1 is 6.02, so it's going to be 6.02, and then you say minus 6.58 absolute value over the standard deviation that is bigger is going to be standard deviation 2, 1.85, because this one is 1.35. So 1.85 is the bigger one, so we're taking that one, 1.85. And the answer, we go to the calculator. So here you're going to do the fraction first, and then you're going to do the absolute value. Absolute value is over here, ABS is the absolute value. The reason for this is because we want our answer to always be positive. If you take a smaller number and subtract a bigger number, you're gonna get a negative number, and the effect size is always positive, it's never negative. So that's why we're putting the absolute value, 6.02 minus 6.58 divided by 1.85. I said divide by, oh, that's why 1.85. That's how you do that, and the answer that you're gonna get is 0.259. So it's 0.259. 0.259. Now there's a guideline for this. You can find it in the slide. If this is 0.2 or closer to 0.2, it's a small effect. Practically non-significant difference. That's how you answer that question. So this is the guideline. I explained it in my uh, tutorial videos, and it's also here as well. So it's also in the slides. Go and look for it in the slides. It's a small effect, practically non-significant difference. That's how we found and answered question 4.4. Yeah, that's the answer. Question 5 is two populations in two dependent populations. There's two dependent populations. There's two dependent populations. There's two dependent populations. Uh, right. So here we are testing uh, before and after. The moment you see before and after, know that you're dealing with two dependent populations. Now let's read the scenario. An army officer wants to see if a strenuous physical program affects the weights of the young men. 7 young men were put through a strenuous physical program by the army. Their weight were recorded before and after the program with the following results. 48.9, 49, 25.9, 26.5, 95.5, 94.2, 84.1, 84.3, 19.4, 19.2, 42.6, 42.7, 46.5, 43.3, and 46.2. Right. So the data reported above are realized from normally distributed populations with equal variances. It is known that the standard deviation of the weight before the program is given by SB is that of the weight after the program is given by SA equals 27.8, and that of the pairwise differences, which is the SD, is 1.81. Right. So they say a researcher claims that the population average weight before the program is higher than population average weight after the program. So we're testing using the word higher. Is going to tell us about our alternative hypothesis. So they say test the claim by answering the questions below. Use significance level of 10%. Right. So formulate the null and alternative hypothesis. As always, we know that we have to write our null and alternative hypothesis, H0 and HA. And HA. So H0, you're going to say the mean difference, meaning before and after, is equal to 0. There's no change. And then the alternative, the mean difference is greater than 0, because he said higher than. So it means there's a positive change in that way. That's how you answer question 5.1. 5.2, calculate the test statistic that can be used to test the hypothesis in 5.1. Alright, so here, oh, there's only that question actually. That's the last question. I don't know why this is 2 marks, because there's a lot of work to do here. Otherwise, the formula that we're going to use says T, because the small sample we're going to use T is equal to uh, what's wrong with this mouse? T is equal to the average difference, the D bar, over the SD divided by the square root of n. Okay, so first of all, we need to find the average difference. So they only gave us the standard deviation of the difference and not the average difference. I don't know why it's 2 marks. It's supposed to be at least 4 or 5 marks, unless if they gave us the average differences. So they didn't give us the average differences, meaning that we have to find the average differences ourselves. So before we do that, let's draw a it's fine. Let us draw a table for the differences. So let's say this is the differences. 1, 2, 3, 4, 5, 6, 7. Since it's 7 of them. Now what we're going to do is we're going to start first finding the differences. 48.9 minus 49, 48.9 minus 49, that is minus 0.1 minus 0.1. 25.9 minus 26.5, 25.9 minus 26.5 minus 0.6 minus 0.6, 95.5 minus 94.2, 95.5 minus 94.2, that is 1.3, 1.3, and then 84.1 minus 84.3, 84.1 minus 84.3 minus 0.2 minus 0.2, 19.4 minus 19.2, that is 0.2, 42.7 minus 46.5, that is minus 4.2. Let me double check. 42.7 minus 46.5 minus 3.8 minus 3.8, and 43.3 minus 46.2 minus 2.9 minus 2.9. And then we have to find the average of this. Let me use the calculator simply. Minus 0.1 minus 0.1 minus 0.6, 1.3, minus 0.2, 0.2 minus 3.8 minus 2.9. Double checks. Minus 0.1 minus 0.6, 1.3 minus 0.2, 0.2 minus 3.8 and 2.9. Perfect. Shift 1, 5, 2 x bar. So our d bar is minus 0.87. Our d bar is equals to minus 0.87. Let me just check if the standard deviation is actually correct. It must give me 1.815, then the standard deviation is 1.81 over there, so it means my differences and everything is correct. Now that I've got everything there, I can find the value of t. The value of t, d bar is minus 0.87 minus 0.87 divided by the standard deviation is 1.81. 1.81. I just showed you that if they didn't give you, you can also find it yourself. 1.81 divided by the square root of 7, and the answer is equal to, let's go and find the answer in the calculator, minus 0.87 over 1.81 divided by the square root of 7, and the answer is equals to minus 1.27 minus 1.27 minus 1.27. I've been here. Minus 1.27, and that is study unit 3. That is the end of study unit 3 as asked here. If they give you the p-value, you compare the p-value against significance level, and then you can find the you can make a decision and draw conclusions. So in this case they didn't give us, so I'm gonna leave it at that. Question, this was question 5. Question 6. Yeah, we are getting close to the end. Question 6. Question 6 is analysis of variance ANOVA. There's only 2 questions on question 6. Question 1 says, state the null and alternative hypothesis used to test whether the means are equal. So let's read the information. A travel agent investigated 4 tourist attractions in Cape Town to determine if there's a difference between the mean number of quarterly visits in thousands at 4 tourist attractions. Consider the following stat 1.3 computer output of the results and answer the questions below. So here is our output. We have the ANOVA table over there. So in most cases, they leave out some questions, some values here missing, and then ask you to answer those questions. In this case, they didn't. So this was an easy question paper, basically. 6.1, state the null and alternative hypothesis. So they said 4. They said 4. We have 4 groups. So it's going to be the null hypothesis. Null hypothesis is going to say mean 1 is equal to mean 2 equal to mean 3 equal to mean 4. So basically saying all the tourist attractions have the same number of quarterly visits. And then for the alternative, you say at least one is different. You just say at least one is different. Just say at least one is different. This one. Just say at least one is different. Just say at least one is different. There you go, and then you get your mark. Use Tukey's groupwise comparison to test to determine which group means do not differ from one another at 5% significance level. Give the relevant p-values. So now when it comes to this, they say which ones do not differ. They say do not differ. So you can literally just look at them here. You can literally just look at them here, and then you look at the p-value. This is what we call the p-values. They said you must use 5% significance level. They must use 5% significance level. So this is the p-value between group 1 and group 2. The p-value is 0.0002. If the p-value is less than alpha, it means they are different. This one is 0.4939. So group 1 and group 3, the answer, the p-value is more than this. So these two are not different. These ones, they are different, is less. This one is less different. This one is less different. This one is also less different. So only group 1 and group 2 are do not differ from one another. Do not differ from one another at 5% significance level. So this is what I was talking about when I said some people confuse this with the practical difference, practical significant difference, which is the unit 5, the one that we just did in question 4. In question 4, I think. Yeah. So here, what you're going to do is you're going to say no, you're going to write the mean for the null hypothesis for group 1 and 3, because those are the ones that you just found already. They are different. Group 1 and 3 are equal, and group 1 and group 3 are not equal. Group 1 and group 3, they are not equal. Now after doing this, the p-value for that is equal to 0.4939. 0.4939. And then you say alpha is equal to 0.05. Now this means that the p-value is greater than alpha. Therefore, do not reject the null hypothesis. Do not reject H0. And then you say group 1 and 3 do not differ. So basically, this question wanted only this part. But then if you can't see it just by looking at these numbers, you need to do all this for all of them. So meaning you want to do group 1 and group 2, then you're going to do group 2 and 3, then you're going to do group 1 and 2, group 1 and 3, group 1 and 4, then you're going to do group 2 and 3, group 3 and 4, then you're going to do group 3, group 2 and 4 again. So it's group 1 and group 2, group 1 and group 3, group 1 and group 4, group 2 and group 3, group 2 and group 4, and group 3 and group 4. So you're going to do 6 of them aside, and then you're going to check which ones are do not differ, because the question says do not differ. If the question said which ones are different, then you're going to say all the groups are different except for group 1 and group 3. That's how you're going to answer that question. But because it wanted the ones that do not differ, it is only group 1 and group 3. Hence, you write it like that over there. And that is question 6. Question 7. Yo, we're still a long way to go. Okay, question 7. Question 7. I need to drink some water. Just a minute. Just a minute. Right, you. I've been talking. I've been talking for I think more than an hour and a half. All right, question 7 says this is study unit 6. This is study unit 6, by the way. So it says suppose proctologists come in 6 varieties: pushy, phobic, kindly, safe, unwidely, and yellow. Because you don't have anything better to do. Oh, really? Wow. Wow. This examiner. Because you don't have anything better to do, you find 155 proctologists and count how many fall into each variety. This generates the following table. So we have the observed frequencies of the proctologists. Now state the suitable, null, and alternative hypothesis to test that the 155 proctologists are distributed evenly across 6 varieties. They are distributed evenly across 6 varieties. So this is how we're going to write the null hypothesis. This is one question that is actually very easy and it's always there. So I don't expect a student to get 0% in the exam, because there is the null and alternative hypothesis question. So the null and alternative hypothesis is written as follows. The first one, I'm going to say proctologists are distributed evenly. They're distributed evenly across the 6 varieties. That's how you're going to write your null hypothesis. And then for your alternative, you're going to say proctologists are not distributed evenly across the 6 varieties. Proctologists are not distributed evenly. That's how you write your. Yeah, that's how you write your null and alternative hypothesis. Proctologists are distributed evenly across the 6 varieties. Proctologists are not distributed evenly across the 6 varieties is your alternative. That's it for question 7.1. 2 marks. Simple 2 marks. Calculate the value of the test statistic that can be used to test this hypothesis. Show all calculations. Okay, so for the first part of this question, uh, we have the formula that says x squared is equal to the sum of the observed minus the expected all squared over expected. Now when it comes to this, we need to know what is the expected frequencies. So the expected frequencies is equal to the percentage or the probability multiplied by percentage multiplied by the sample size. So because they didn't give us the distribution of this maybe previously, for someone who didn't have anything better to do as well and found the 155 proctologists. So because we don't have that information, we assume that they are evenly distributed. Hence we said they are distributed evenly across 6 varieties in our null hypothesis. So meaning that we believe that it's 1 over 6 for each and every one of them. 1 over 6, 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 and 1 over 6. So meaning that we're going to say 1 over 6 is our proportion or our percentage multiplied by 155 multiplied by 155, and the answer that we get here is the expected frequency for all the varieties. So meaning that if there were 7, we're going to say 1 over 7. If there were 4, we're going to say 1 over 4, and so on. So you do that when you don't have the proportions for the research that was done before the research that is being done at that particular time. So 1 over 6 divided by 155, so it's 1 over 6, it's 1 over 6 multiplied by 155. So this answer will be the answer for all of them, 25.83. 25.83. So you write this as it is, even though proctologists might be people, or I don't know what a proctologist is basically. Let's say it's people or whatever living organisms that is. So we don't, when it comes to the expected frequency, we don't change this. We don't change this. We don't round it off to 26, like for example saying there is no half a percent. But if you want to be safe, you can say approximately. So meaning that you can say approximately, you can use this instead of just say equal. You can say approximately 25 point, you can say it's equals to 25.83, which is approximately 26, but you don't have to do that. You can actually just leave it like this. I prefer to leave it like this. And then now that we have the observed here and we have the expected here, then we can substitute into our equation and find the answer. So I'm going to do this at the same time. You can write it down, but I'm just going to say x squared is equal to and find the answer. So you can write it down and say, okay, observed. I'm going to show you how to do it here on the calculator, so you can write it down first and then do it after. Your observed is going to be 28, so it's going to be 28 minus expected is 25.83 squared over 25.83. So you must write this down here to show how you substituted. So you must write it down here, and then you're going to say plus. I say plus. The following one is 38. No, let's do this first. Maybe 28 minus, not 28, 38, sorry. 38 minus 25.83 squared over 25.83. So you do this for all. And then we have 17 minus 25.83 squared over 25.83. And then you do the next one. We're running out of space, as you can see, so I'm just gonna do this quickly. 17, then we have 27 minus 25.83 squared. We ran out of space, so if you run out of space, the last one that we did, it was 17. Now you just press equal and then you add, you continue with the other ones. So it's going to be 27. It'll be 27 minus 25.83 squared. So it happens when you pressing the calculator using a lot of numbers. So it happens, so you should just say equal and then continue, or else you can do this one by one, writing the answers down and then adding them at the end. You can also do that. 18 minus 25.8 25.83 squared over 25.83. It's going to say equal here and add the last one to avoid running out of space. So it's going to be 27 again. 27 minus 25.83 squared over 25.83, and the answer is 11.414. 11.414. Yeah, so that is how you find that answer. So just make sure that you double check your calculations, because I am also a human. I make errors. So if maybe somewhere I made an error, that doesn't mean that I wanted to mislead you. No. So I just showing you how to do it, and yeah, you should do it like that. Observed minus expected. This is expected over expected. Don't forget to square that as well over there. So this is the answer that I got. If you got a different answer, just double check, and then if I'm incorrect, or maybe if I made a mistake, then it means your answer is correct. But the approach is the one that is important. So remember to write the steps, so that even if the final answer is incorrect, but then because you showed how you found the expected frequencies and how you substituted the equation in the equation, you will actually find you'll actually get marks for those. Question 7.3 says, suppose that the p-value corresponding to the test statistic in 7.2 is equal to 0.0583. The p-value is equal to 0.0538. 0.0538. I said 83, sorry. 0.0538. I guess I'm getting tired. 0.0538. Now, the p-value is more than alpha. Alpha is equal to 0.05. 0.05. Significance level is 0.05. So now alpha is more than, p-value is more than alpha. So if the p-value is more than alpha, we do not reject the null hypothesis. The p-value is more than alpha, so we do not reject the null hypothesis. And if we don't reject the null hypothesis, then we say proctologies are distributed evenly across 6 varieties, because that is what the null hypothesis say. They are distributed evenly across the 6 varieties. That is how you answer question 7.3. Let's go to question 7. Question 8. Let's say question 7 again. Question 8, it says, in an experiment to determine the most advantageous position in a machine to mount an electronic component which may be prone to failure due to excessive heat buildup, 300 machines are tested with 100 randomly chosen example of the component in each of the 3 positions. The results obtained were as follows. Question 8.1. 8.1 says, formulate the hypothesis to test whether there is independence between component failure and mounting position. Between component failure and mounting position. Okay. So the null hypothesis and the alternative hypothesis. The null hypothesis will say that component failure and mounting position are independent. So the null hypothesis is always independent of each other. So it's always this variable is independent with this variable, and then for the alternative you say they are dependent. Component failure and mounting positions are dependent of each other. That's how you write null hypothesis and alternative, and you get 1 mark. Question 8.2, construct the table similar to the one given, showing what the expected frequencies would be if the two variable component and component failure and position were independent. So they say construct a table that is similar to this one. So I'm just going to take this table, Control C, Control V. I'm going to take this table here because they say I must construct the one similar to it. There we go. Let me just take no, you know what, let me do this. Let me see if I can do some erasing of some parts. Okay, no, I can't. Let me use a pen. Let me customize it to be a thick point pen with a white thing here, so I can just erase these numbers here. So I can erase these numbers. I want to erase these numbers. I want to erase these numbers. There we go. Copy, paste. Yeah. You can go. You can go, and then you are needed. Okay, cool. Okay, cool. So now let's do some totals. So remember, we need the totals for this total. We need the total. So we're going to say the total for this is 60 plus 40, 100, 30 plus 70, 100, 100. So all the totals is 100, 100, 100. Remember, they said they use 300 machines, so the total is 300 at the end. 300, and that is 100, 100, 100, and 100. That is equal to 300. So that's what they want you to do. Now this is equal to 50 plus 40 is 90, 120. This is 120, 120. So this one is going to be 120 over here, 120, and this one is going to be 180, obviously. So it's 110 plus 70. Yes, it's 180, 180, and then it's total here. Total is the total. What is the total? Now we're going to use these totals to find these values in here. So that's what they want you to do when they say construct a table that is similar to that. Now let's do that. We're going to say 120 times 100. So that is how we do this. 120 times, for this one we say 120 times 100 divided by 300, which is the overall total. 120 times 100 divided by 300 divided by 300, answer is equal to 40. So the answer here for this is going to be 40. going to be 40 for this one here. And if it's 120 times 100, so this one is going to be 120 times 100 as well. This one's going to be 120 times 100 as well. So meaning all these ones above is 40, 40, 40. So it's going to be 40, 40, 40. I can just Control C, Control V, 40, Control V, 40. Because it's 120 times 100 divided by 300 is this number. 120 times 100 divided by 300 is this one. 120 times 100 divided by 300 is this one. So it's the same number because of we're using the same numbers. Then we can do the one for 180. It's going to be 180 times 100 divided by 300 is 60. So it means it's going to be 60, 60, 60 for all these other ones. So it's going to be 60 here. So going to be 60 for this one. Control C, Control V, Control V. It's going to be 60. It's going to be 60. It's going to be 60. So that is the table they wanted you to draw. That is the table they wanted you to draw. Construct a table similar to the one given. So that is the table that is given here. This is the given table. This is the one they want you to draw. 8.3. Calculate the value of the appropriate test statistic that can be used to test the hypothesis in 8.1. So we want the test statistic here. The formula that we use is the same that we used before, as x squared. Where is that formula? Where is that formula? Let me just go up and copy it. The formula that they want us to use, they actually want us to use this formula. They want us to use this formula. Control C. Let's go down. Control V. This is the formula that they want us to use. This is the formula they want us to use. And then we have the observed, we have the expected. We have the observed, we have the expected. So we're going to go to the formula, go to the calculator and find those values. So you can write them down, but I'm not going to do that. I want you guys to work on that. So you're going to write them down, and then when you're done, you can actually come to the calculator. Now I'm going to put the calculator here in the middle so I can see both the observed and the expected. Now the first one is going to be 40 minus 40 squared. So this one is going to be 0 actually. It's going to be 40 minus 40. So it's 0 squared over 40. So it's just going to be 0. So the first one I'm going to do it. Second one is 30. I'm going to do the second one. I also want to save the space because the calculator doesn't write those many numbers together. So it's going to be 30, which is the observed, minus the expected is 40. The expected is 40 squared over 40 plus 50 minus 40 squared over 50. 50 minus 40 squared over 40. Sorry, over 40 plus 60 minus 60 squared is 0. Squared is 0 over 60. It's going to be 0. So I'm not going to include that as well. I'm going to leave that one out because plus 0 is just a 0. But you must write it down, remember. You guys must write it down. So I'm just skipping it to save time and space in the calculator, like I said. So this is going to be 60. No, 70 minus 60. 70 minus 60. So it's going to be 70 minus 60 squared over 60 plus 50 minus 60, 50 minus 60 squared over 60 equal 8.33. So the answer for this question 8.3 is equal to 8.333. If you want to write 3 decimal places, 8.333. That's how you answer question 8.3. Remember to substitute before you write the final answer, because they give marks for those substitutions as well. So the very same way I was doing on the calculator, you do it writing down. That is question 8.3. 8.4, the p-value of the test is 0.0034. Is there a relationship between component failure and position? The p-value is 0.0034. So they said you must use alpha of, did they tell us? They didn't give us alpha. Did they give us alpha? No. They just said the p-value of the test is this. So if they didn't give us alpha, we assume alpha is equal to 0.05. So the p-value is equal to 0.0034, 0.0034. Alpha we assume to be 0.05 equals to 0.05. Now if this is the case, then the p-value is less than alpha. The p-value is less than alpha. So the reason why we're choosing 0.05, not 0.01 and 0.010, there are 3 different types of alpha. It's 1%, 5%, and 10%. Now the one that is in the middle is 0.05. So we choose that all the time if they didn't give us the significance level. That is what we do. And even if we chose 0.01, this will actually be less than. Even if we choose 0.10, 10%, this will still be less than. So the p-value in this case does not change. The significance level does not change the decision of the p-value. So the p-value is less than alpha. If the p-value is less than alpha, then what we're going to do is we're going to reject the null hypothesis. We're going to reject the null hypothesis which says they are independent, and then we're going to say component failure and positions are dependent of each other. So meaning there is a relationship. There's a relationship between you can actually just take it here, man. You can just take it from this. You can take it here and say we do not reject. You can say no, reject the null hypothesis. Therefore component failure and mounting positions are dependent of each other. That is unit 6. And the last but not least question, 10 marks. 10 marks question. That unit 7. The degree to which a baby's health is influenced by parents who smoke is an important research area. The next table shows the measurements of urinary concentration of nicotine, core nicotine, an important metabolite of nicotine, taken from random babies, some of which were exposed to parents who smoke and others who were not. So not exposed is 2, 4, and then exposed is 2, 4, 6. Use the rank sum test to determine the significance level percent whether the median core nicotine levels of babies exposed to smoking is different than the median for babies not exposed. So they said different. So now we're using the median here. This is what we're going to write our null and alternative hypothesis as. So the null and alternative hypothesis will be written like this. The null hypothesis says N1 is equal to N2, N2, and is equal to N2, and then the alternative hypothesis says N1 is not equal to N2, N2, not equal to, not equal to N2. So this is how we write our median. We use the N, not the U, like we did with question 3, 4, and 5, I think. Yeah. Now they say we use the rank sum test, right? So this is our first step. The first step is to write the null and alternative hypothesis. The second step is to specify significance level and test statistic. Significance level is equals to alpha, which is equals to 0.10, 0.10, and the test statistic that we're using is the Wilcoxon rank sum test, which is W. W is equal to uh, sum of the rankings, sum of the rankings, sum of the rankings for the first sample, 1 here. Sum of the rankings for the first sample minus, this mouse is no longer writing correctly, minus N1 minus, no, N1 into N1 plus 1, sorry. N1 into N1 plus 1 over 2. That is the formula, is there in the slides, in the textbook as well. So that is how you write it there. And then step number 3 is to calculate the test statistic and critical values. The test statistic is equal to this. So now we have to do the rankings for these numbers here. We have to do the rankings for these numbers. So we're ranking these numbers at the same time. We don't rank the not exposed first and then we're ranking exposed after. No, we don't do that. So we're going to do it at the same time. So now the first number that we're going to write is going to be for this one. So ranking number 1, let me actually take a snippet of this. Let me take a snippet of this. Copy, paste, so that I can do the rankings well here. Right. So the rankings, let me just erase this for now. I will do it after. No. I want to move this so that I can do the rankings. Right. So 15 is the lowest number. So 15 is going to be ranking number 1. Ranking number 1. 15, 16, do we have 16, 17, 18, 19, 20, 21, 22, 23 is ranking number 2. 23, 24, 25, 26, 27, 28, 29 is ranking number 3. 29 is ranking number 3. 30, 31, 32. So 32 comes twice. So it's going to be ranking number 4 and number 5. So we add the two rankings because they are equal, these numbers. So it's ranking number 4 and number 5. So it's 4 plus 5 divided by 2. So this is going to be 4.5. 4.5. And this one becomes 4.5 as well. 4.5. So now we have 31, 32, 33. So it's 1, 2, 3, 4, 5. This becomes ranking number 6. This becomes ranking number 7 now. This becomes ranking number 8. This becomes ranking number 9. And this becomes ranking number 10. So if you have two numbers that are equal, you share the rankings for the two numbers. So it's ranking 4 and 5 and ranking 4 and 5 to make 4.5 for each, like I did here. And if your rankings are correct, the last ranking should be equals to the last ranking should be equals to the sample sizes of the two combined. Unless if the last number is also repeating, then you say this plus this divided by 2. That's how you do the rankings here. Going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the last ranking is number 10. Now that we've done the rankings, then we can calculate our Wilcoxon rank sum test. So this is equal to, we said is the sum of the rankings for the first sample. The sum of the rankings for the first sample, sample 1. Let me actually write this correctly. The sum of the rankings for sample 1 in brackets. So now, that is what we're going to do. We're going to count the rankings for the first sample is 1 plus 4.5 plus 6 plus 7 plus 6 plus 7. So is equals to 18.5. So that is going to be 18.5 minus uh, n1 is 1 2 3 4 is going to be 4 into 4 plus 1, which is 5 over 2. So this is equal to 18.5 minus 4 times 5 is 10. 4.5 is 20. 20 divided by 2 is 10. So meaning W is equal to 8.5. 18.5 minus 10 is equal to 8.5. 8.5. Okay, cool. So now that we have this and also have this, then we have to calculate our uh, critical values. We have to calculate our critical values. So now to calculate the critical values, because we're testing different, it's a different, our alpha needs to be divided by 2 because it's two-sided. As a two-sided hypothesis, as you see here, two-sided. So meaning we have to divide our alpha by 2, that is the protocol. So we're going to firstly divide our alpha by 2. To me, the computer, it has started its shenanigans. Let's just wait for it to sync and finish. Oh boy. Ish, the network, guys. Yo, this network. Uh, okay. We are almost there. We're almost done. Okay. Sorry for that. Alpha over 2. Like I said, we need to divide our alpha. So that was 0.1010% divided by 2. That is 0.05. 0.05 is our alpha over 2. That's how we do it there. And then we need to find the critical values. The first critical value is W of uh, N1, comma, N2, and alpha over 2. Alpha over 2. And then the second critical value is N1 multiplied by N2 minus W of N1, comma, N2, and alpha over 2. Yo, this mouse, guys. Alpha over 2 over 2. So we need to find those two critical values. And to do that, there's a table for the critical values of the Wilcoxon rank sum test at the end of your. Someone sent them to me. I remember. Or did I send them to myself? Let me just check here. actually yeah, these are the table signs. Let me just open them. There we go. There we go. There we go. So we need these tables. These tables here. So this is the critical value for the rank sum test. So now the first one says the W of N1, N2, and alpha over 2. So remember alpha over 2 is 0.05. So the critical value N1, N2, we're going to start with N2 first because that is how the critical values are written here in this table. So N2 in our case was equals to 6. So meaning we're going to focus on here where N2 is equal to 6. You see N2, here's 3, here's 4, here's 5, and here's 6. So N2 is equals to 6. So you're going to focus on this part of the table. This part of the table. N2 is 6, N1 is equals to 4. So you're going to focus on 4. Then we go to alpha equals 0.05, which is here. This is alpha equals 0.05, and the critical value there is equals to 3. So you see the critical value is equals to 3. And then the second one says N1 times N2 minus the critical value that we just found here. What is the value of N1? N1 is equals to 4 multiplied by N2 is equals to 6, and then we minus 3, which is this one over here. So this one is equals to 4 times 6 is 24. 24 minus 3 is equal to 21. That is our uh, two critical values. Now that we have the critical values, then we're going to state the decision rule. So the decision rule says we reject, because it says it's two sided. We're going to reject if uh, W. Let me just write it here. Reject if W is. Let me just do it here. Reject if W let me actually do this. Reject if W is less or equal to, if W is less or equal to the first critical value. If W is greater than the equal to is greater or equal to the first critical value, which is this one, this one. So I'm going to copy, Control C, Control V. So you reject if this is the case, or or you reject if Control C, Control V. Reject if, you also reject if W is greater or equal to, if W is greater or equal to this part. So let me just do this. If W is greater or equal to this part, Control C, Control V. If W is greater or equal to this part. So that is how you do this. So this is our decision rule because it's two-sided, meaning that if W, remember W was equal to 8.5, ne? Let me just write it again here. W is equal to 8.5, is equal to 8.5. Now, if W is in between these two numbers here, if W is in between these two numbers, this and this, you do not reject. So you can see that W is 8.5, so W is not less than 3 and W is not more than 21. So meaning in this case, you're going to say do not reject the null hypothesis. You're going to say therefore, do not reject the null hypothesis because W you can just say because W is in, you can say is in between, the two critical values. W is in between the two critical values. And then when you're done, you can go back and make draw conclusions based on the initial statement. Remember, making decisions based on the initial statement. The initial statement, we are testing if uh, the median nicotine level for babies exposed to non smoking is different. So because we didn't reject the null hypothesis, you're going to say we don't reject the null hypothesis, then you're going to say uh, the median nicotine level for babies exposed to smoking is not different to those not exposed to smoking. The median nicotine levels for babies exposed to smoking is not different to those exposed to smoking. And that is how you answer hypothesis. The Wilcoxon rank sum test. So 10 marks for this. 10 marks. So we start here. Null and alternative hypothesis. No, it doesn't start there. It starts here. Null and alternative hypothesis. And then let me just zoom this out a little bit. You do the rankings, then you calculate the test statistic, calculate the critical values, you state the decision rule, you make a decision, and draw your conclusions. And that is the end of the question paper. You get your 100%, you pass statistics, and then you pass other modules as well, then you get your degree. Otherwise, there are other questions that are not included here, so it means that it will take some time to master everything. So I did take a long time to actually complete this because there were a lot of questions and I had to explain each and every part. So now, yeah, that is how you answer questions for statistics 124. And all the best, guys, with your exam. All the best. I'll see you guys in the next video. Will there be in the next video? Hopefully there will be a next video. See you guys next time.